voice AI in the enterprise. Voice AI is having a bit of a resurgence, I would say, in 2025.
NHS 111 here in London. So we put the speech recognition technology on the front of the 111 service. And what it's created is over 90,000 hours of freed up health advisor time.
90,000 hours, did you say that?
Yeah, hours, not just minutes.
What are the recent developments, I suppose, then, that have enabled that kind of output?
Accuracy is fundamental. It's the most important thing. And that's not just accuracy from a point of view of us hearing a word and outputting it. You have to understand the context of a conversation.
And obviously, who doesn't want to be a third more efficient?
Perhaps you could give us an example of what scale looks like.
Say UK Power Network. Say the lights go out in Soho, suddenly you're deluged. You've got hundreds of thousands of people contacting the service simultaneously. Almost full automation. So I think it's 93% of all the calls are fully automated. I suppose assumption is that they want to have fewer people and cut the cost, etc. But really what most are aiming for is...
What we're also doing with our conversational AI API is...
And actually, the big thing that excites people in the customer experience and contact center is...
Cool. Hello, everybody. Welcome to this session, Fireside Chat. Very nice environment we're in here. My name is Kane Sims. I'll be the host for the proceedings today, where we're going to be talking about voice AI in the enterprise. Voice AI is having a bit of a resurgence, I would say, in 2025. It seems to be the hot topic that everyone's talking about, so I'm really keen to get your insights, Paulina and Martin. I'm joined by Paulina White, who's a Senior Director at Speechmatics, and Martin Taylor, who is the Deputy CEO at Content Guru. So why don't we start with a few introductions, Paulina, and maybe tell us a little bit about yourself, and for those that don't know, a little bit about Speechmatics.
Yeah, thank you. Good morning, everyone. So I've been with Speechmatics now for 4 years, working in several different roles, but as you say, more recently as a strategic director, really looking after our larger clients. So Content Guru is one of our large clients, and working in public sector, so doing a lot with government agencies. And that's sort of given me insights into sort of regulations coming out. So when we start talking a bit more today about the voice AI, you know, how we're looking at compliance and complaints around that place.
Nice. Thank you. Martin?
I'm Martin Taylor. So I've been in the business since the start as a co-founder. So Content Guru goes back to 2005. And before that, Redwood Technologies Group, which is the kind of forerunner and owner of Content Guru since 1993, a worryingly long time now. And fiddling around with computers and things since age 10 or so.
Wow.
So Content Guru is very much about the customer experience and the technology behind contact centers, chat, and this kind of omni-channel customer experience.
Cool. So I mentioned there voice AI is seemingly, I don't know whether resurgence is the right way to say it, because I think it's for Speechmatics and Content Guru, I imagine voice, well, definitely for Speechmatics, has always been the main priority. But it seems as though 2025, the world seems to have woken up to voice AI to some degree. I don't know if you concur with that in terms of the level of awareness and demand and all that kind of stuff around voice AI today.
Yeah, I think historically, if you look back at Speechmatics, when we originally founded the business, voice was really probably only used in very few use cases. And traditionally and typically at that time, it was for captioning and subtitling. Within contact center, it's been relevant for several years, but really sort of as a post-processing piece. And of course, with the emergence of AI and ChatGPT and generative AI, then everyone's looking to develop agents. And so we're seeing a sea of change coming into different use cases where speech can be used.
And for Content Guru, being contact centers being your kind of like, you know, real focus, presumably voice AI and being able to get insights into the conversations that are happening and do something with them. I imagine that was something that you were focusing on. When did you start focusing on that kind of thing? Yeah,
I mean, before contact center, we were in automation. So we used to do all the big TV votes and lots of those big interactive automated services. So actually, we've been working with speech recognition technologies since the very beginning of the business. I remember one of my first overseas trips in '93 was to Boston, which was to VPC, which was then the kind of state of the art in speech recognition. And to Paulina's point, the the early uses were fairly mundane. It was capturing digits, so things like voice dialing could happen because, believe it or not, DTMF phones were still not ubiquitous at the time. So you wanted to kind of capture any interaction, voice was the way to do it. But it was quite hit and miss. And it improved steadily over time. And then suddenly in the AI era, with people like Speechmatics coming along, it's really moved it up several notches to the point we can have these really conversational interactions now.
Like, I think everyone's had the experience of an IVR system of some description. One, they're not very helpful anyway, because press 1 for this and press 2 for that and press 3 for this and press 9 for that. You're just there forever, and it can never really understand exactly what it is that you want, unless what you want is confined within those 6 options. And those things that you were talking about, the early sort of speech recognition systems, like for credit card payments, say card, like those things were just horrific, weren't they? So, Paulina, what's changed then compared to what's out there and what many enterprises are still using today? What's changed based on where voice AI is today?
I think it's more around the natural language processing and really understanding what a conversation is. I mean, if you take those examples that you've just used, a bit like Alexa and some of those other products where it's very short form, so it's listening to a word and it's using that word to go and have a downstream process. But actually, you really need to be in a situation now, particularly with voice agents, where it sounds very natural. And so the whole natural learning and process and conversational piece comes into that. And that's really how we train our language models. It's how we've always trained our language models. So we haven't changed what we do. It's almost like the voice AI piece has caught up with Speechmatics technology, but it's making that much more natural. And so that's the emergence now of coming out where you're not fooling people that they're talking to maybe a chatbot, but that chatbot experience is much more natural. And so the conversation flows. And that's why it's just exploding in different areas that just makes it much more interactive for people to work with.
Someone once explained to me that there's some continuum, I don't know exactly scientifically what it is, of kind of 0 to 5 as to how human an interaction is. And apparently a contact center agent never achieves 5. But once you're past about 3.5, then the interaction becomes much more fluid and human. So obviously if we think of these early IVR style voice interactions where instead of pressing 1, I say 1, or I say sales or technical support, that's a very mechanized, stilted interaction. Whereas the technologies now enable that, surpassing that 3.5 mark where you start to then have the fluid interactions. And of course, then you can capture a lot more information. Pressing 1 to 9, and humans can only remember up to 6 at best. You're only going to capture up to 6 options. Then thereafter, you could be going into layers of IVR, which is very frustrating, the high customer effort score, as we call it. Whereas actually with great natural language processing, you can get straight to the point as to what it is that people want. Take them straight there. Think of it like a limitless IVR.
There was a really good analysis done a couple of years back from Nationwide Bank, and they did some analysis across all their different channels, and they found that their chatbot had something like 120 different intents, so 120 different reasons for people, or 120 different things they could recognize, essentially customer needs. The IVR options, if you counted up all of the option 1, option 2, option 3, you had about 90. Agents, when they answered the phone, had something like 250 disposition codes that they could log after the call. So 90 you could choose from, but 250 they could log. And then when they did the broader analysis, they found that actually customers there was about 360 reasons for contact. Not one channel was ever picking up all of them, and largely because I think of the limitations you were talking about there, which is there's only so much you can cram into an IVR. There's only so many, things that a user could say at a really basic level, like cards not working or whatever. Whereas I think now, a combination, I think, of the voice AI technologies and perhaps some of the LLMs behind the scenes that are able to then understand what somebody means when they describe a situation. Excuse me, because sometimes customers don't necessarily know, I want to block my card. They will just say, I was on the train and I've left my bag and my card's in it and I don't know what to do. So it's kind of like having the combination of the voice AI to really get accurate understanding of what's being actually said, perhaps in combination with some of the generative AI technologies to be able to then turn that into something useful, perhaps.
Yeah, it's for processing and the comprehension, isn't it, really? So one of the examples we like to cite is NHS 111 here in London, which the London region is obviously the largest part of NHS demand-wise. So we put the speech recognition technology on the front of the 111 service, which traditionally was, you press 1, you press 2, you listen for several minutes to lots of announcements telling you why you shouldn't have called. And then eventually you'll get through to a health advisor who's obliged to work in quite a machine-like way, working through some algorithms. So we had the idea, let's just put on the front a why are you calling type question, obviously phrased nicer than that. And then we've captured, I think so far, 3.35 million of those utterances since we turned the service on. And initially, NHS have their own data scientists, obviously we're a huge organisation, and they looked at what was being said, and they came up with, I think, 43 categorizations, reasons for calling. Obviously a lot more than you could capture through an IVR. But when we then applied our methods of AI methods and machine learning methods, we quickly got to 180 categories, so much more granular in terms of the reason for the call and where we can take you. So now 2.5 million of those calls we've been able to take to different dispositions where they can get specialised service, maybe self-service, or maybe more information is submitted, rather than going to this very algorithmic human. So that's a hugely better service. And what it's created is over 90,000 hours of freed up health advisor time. So there's more time available to talk to people and actually deal with those cases that can't just be resolved very, very quickly and easily in an automated route. So that just wouldn't have been possible without, obviously, great technology to put on the front.
90,000 hours, did you say that?
Yeah, hours, not just minutes.
90,000 hours worth of time saved. That's amazing, isn't it?
Yeah. And I think, from what Martin's saying there, for that process, I think that's where AI can really complement the agent as well. If you go back to, initially when broadband was introduced, if anyone was born then, I certainly was, and you would ring up your provider, the agents were very scripted, and it didn't matter what you told them. They would literally work through those responses in a process, because their role at that time was to get you off the phone as quickly as possible because they had a queue. But bringing in AI to do that analytics or do that analysis and understand really what the caller is saying, and then use that content to build those processes that Content Guru have done, not just for the NHS but for their other use cases, means that it is freeing up the agent then to be more human when somebody needs to go and speak to the human. But the automation and the AI piece is going through that process in a human and empathetic way to make the user feel like that they are engaged. And they may not need to go to a human. So that's then freeing up the people to do the work that they need to do when they're actually on a conversation.
Yeah. So what are the things then that perhaps more like what are the recent developments, I suppose, then, that have enabled that kind of output? Because again, if we go back to the days when it was just keyword recognition and things like that, what are the things that Speechmatics cares about in terms of enabling businesses like Content Guru and subsequently their clients like NHS London? What are the things that you care about? Is it speed? Is it accuracy? Like, can you share a little bit about what matters to you in terms of the creation of this kind of technology?
Yeah, all of the above, really. So when you look at how we produce our speech engines, accuracy is fundamental. It's the most important thing, and that's not just accuracy from a point of view of us hearing a word and outputting it. You have to understand the context of a conversation to be able to obviously put that command through to a large language model or through to a process flow. But having that accuracy and at really low latency is super important. So there are other providers out there that have accuracy that's okay, the latency is not so great, or have it really fast and the latency is appalling. We had a working example that we were looking at with a delivery company where they were using a chatbot or IVRs using another provider, and the response was really fast, and they were advertising, we get really fast response times, but the response was, can you repeat that please, because the engine didn't understand what was the chatbot didn't understand it. Yeah, exactly. So for us it's around having that real high accuracy, and we pride ourselves on building our language models to understand every voice. And what we mean by that, it's somebody that's speaking a language that may not be their native language. So the accuracy isn't just about outputting a word, it's can I understand somebody's accent? Is it a dialect that they're speaking? If you look at the number of people in the UK alone that are hard of hearing, that their diction may not be very clear. So training our language models so it does literally understand tonality and pace and those different outputs. So accuracy is really key. And then being able to identify who said it. And, you know, if you've got a two-way conversation and there's an agent and a client on the end of the phone, you want to be able to distinguish who said what, because for post-processing and doing analytics is, did the agent say the right thing? Were they compliant? What was the sentiment of the person calling in? So speed, accuracy, diarization is important, and obviously having the scalability. So at scale, Martin will give some examples later of some other use cases that during COVID, bringing people completely into an automated solution, you had to scale very quickly. But if you don't know what those traffic patterns are going to be, then we just need to make sure as an organisation that we're completely scalable and robust as well.
In terms of accuracy, I think performance is definitely improved, I think, across the board from a speech recognition perspective. I think the word error rate, I don't know what the word error rate of your latest models are, but I was reading somewhere like 1.3% is kind of like, you know, that's like unbelievable. And so, but still, and this is probably down to the technology used in something like Siri, but whenever I say Kane, all the Apple dictation always thinks I'm saying Ken all the time. It's crazy. But I understand why, though, because it sounds like a bit like an American saying Ken when I say Ken in my accent. But talking about scalability, what kind of, like, you know, you're alluding to there at COVID, there was the requirement for being able to scale. Perhaps you could give us an example of what scale looks like, and then perhaps you could share a little bit about what needs to be done to enable voice AI at scale, perhaps. So Martin, can you share a little bit about what scale looks like?
We deal with scale all the time. So we look at someone like a energy company, say UK Power Networks, the largest distribution network operator in the UK. So they have effectively a monopoly of London, the southeast and the east of England. So in regular times, they have a large contact centre, is well able to deal with every call instantly. But say the lights go out in Soho, as we've seen has happened, suddenly you're deluged. You've got hundreds of thousands of people contacting the service simultaneously, which is what kind of takes us back to our mass call days of a TV and Ant and Dec put the number on the screen, and you've got to stay up and not go down and take the network with you. So dealing with that scale, in the case of UKPN, they switch modes. So they go to almost full automation. So I think it's 93% of all the calls are fully automated. So you've called 105 or one of the other numbers in this critical national infrastructure service. You'll speak your postcode, so we know where the property is. We'll then be very quickly looking up high voltage, low voltage information on the networks, triangulating that to where you are. We'll tell you what's gone wrong, that maybe the substation in Dean Street was inundated. We'll tell you what's being done to fix it. There's an engineer on the way to site with a generator, for example. We'll tell you when the power is expected to come back on. You can then register for automated updates, and just that last bit cut down the repeat calls by 50% at a stroke when that was introduced. But if you are on the vulnerable list, maybe you're a care home with 30 elderly people in it, or you've got a dialysis machine, or any one of a number of other reasons why your number and location will be on a vulnerable list, you will go straight to a call handler who's trained to expect you and know exactly how to help you. So by effectively draining that water level of all the mass of calls, which we can process much more ably with zero delay, then we're freeing up the personalized service for the people who really do need that help. So scale doesn't need a pandemic. But when there is a pandemic, you need to scale. Mm-hmm. So in my 111 London example, we were already running that service when the pandemic hit, and it went to 14 times the level of demand, more or less overnight. Ministers were on TV telling everyone to call 111. They hadn't necessarily told the 111 people that they were going to do that. So everyone did. And so you not only had 14 times the traffic, you had 50 times the duration as we're dealing with this mass of demand. And then obviously you have to start triaging that and dealing with it very quickly. Right across the board, you had lots of people put on furlough. People wondered, what's this furlough? So suddenly our lines into the DWP for universal credit, those were deluged. We had a queue limit, which we set for all customers, really. And their queue limit was 10,000, which is fine. We normally have a queue of maybe 50, 60 people. So very quickly we hit that 10,000 buffer. And so we had a call saying, we need to increase the queue size. Well, have you actually got more people on the end? No, we don't. So therefore, you need to see how can we process those calls better. So we've always been about dealing with that scale demand in this very robust way, with our 99.999% SLA, which means I think 5.25 minutes a year of service outage. And we run emergency services too, 999, pretty much all UK ambulance, many UK police forces. Those calls must work. So we have an above 99.999% SLA for those users. So handling scale, being very robust and keeping it very safe, that's really the aim. But if you go back to the processing, so the processing of that earlier example, the 111 service with the YE calling, we actually worked iteratively through many models, from multi-layer perceptron, through support vector machine, through vector search. We looked at large language models. And finally, we built a small language model, created these 180 categorizations, and got those medically signed off as safe. And then we could operationalize it immediately, running at 30 milliseconds. So you wouldn't know that there's processing going on. It's just a real-time conversational speed at the scale as well. So speed, scale, safety.
Interesting. So that fine-tuned small language model essentially is on the front end classifying incoming calls and then routing them to the right place.
Exactly.
Am I understanding that right?
It's a retrieval augmented generation. So you're not just hearing some words and acting. You're hearing some words, referencing, and then acting. And obviously doing that in 30 milliseconds.
And that then, I suppose, I imagine, would not cause Speechmatics a problem, but in terms of your product development, this is probably something I would imagine you think a lot about, which is that in a real-time conversation with a user where, 300 milliseconds is typically the response time for a human. So if we're in the middle of a conversation, 300 milliseconds is normally the response, when you would start responding after I've finished talking. So Speechmatics is part of the bigger chain here, whereby the text, the speech coming in needs to be transcribed, then needs to go off to that fine-tuned small language model, then needs to go and do the retrieval of whatever the classification is, then it needs to go and do something. So presumably that puts Speechmatics in a situation where speed, that's the importance of speed in reality, isn't it?
Yeah, and with our real time, so everything we develop in real time first, and with our real time, we have been looking at and have recently just improved how our response times work, and actually we've had scale in that. For scale, I don't mean large scale. I mean in terms of being able to tune up or tune down how the response works. So depending on what delivery you need. So if you're looking at closed captions, for example, if somebody's doing live TV, then obviously you want the captions to appear as they're saying it, because otherwise it's then not readable. But also with live TV, they need to be able to edit out any profanity. So you do want a little bit of delay going there. But when you're talking about interacting to small language models or large language models, that accuracy and that speed does really need to be there. So we can dial down and have that latency much, much lower. So deliver the output at something like 300 milliseconds from the speech engine. What we are also doing with our conversational AI API is taking away kind of the pitfalls that people have experienced with building out agents, where you have a delay speaking to the large language model or waiting for that response, and also taking away interruptions. So you don't want to send a response from speech to a language model, a question, for example, and then the language model is determined to answer all of that questions. We've dealt with interruptions and end of turn, and that's where you get that naturalness. But the speed of output, we can make it very, very, very fast. But you do need to make sure that you maintain that accuracy, because otherwise the downstream process is not going to give the response that you need. So we focus very much on, yes, getting that low latency, but making sure we maintain that accuracy.
And how do you prepare for that level of scale that Martin was referring to there? You know, was it the 111 you said grew 14x during COVID? Is that something, how does Speechmatics kind of go about preparing for that level of scale?
In terms of the language models, we're really an API. And so we're providing the engine, and Content Guru are building the race car around it effectively. So in terms of the scaling that they're talking about, or that Martin's talking about in terms of those calls, it doesn't really change how we process. We do need to make sure that we've got enough concurrency. So if they're suddenly going to start processing lots and lots of calls, we need to make sure that we can scale up the engine to be able to respond at that level. But we, in terms of our SaaS solution, we host that with one of the hyperscalers, so we have that scalability. But Content Guru also deploy our containers. So we basically have containers that we can deploy. It's in GPU, and they deploy in their own private environment. So it means they have accessibility to scale that as fast as they want to. Also, in terms of scalability, we have, from a SaaS perspective, we have different endpoints around the world. And so we have a couple of regions within the US, we have a couple in Europe, we have some in Australia. And if we need to scale up more endpoints, we can do. So it means that we make sure the traffic is, from a data sovereignty perspective, is processed in the right location. But it does also mean then that we can load balance that traffic across the different regions to make sure that we have that scale. And as yet, thank goodness, touch wood, we haven't come to any scenarios where we've had any challenges with that traffic coming through. And we do have some other examples of effectively calls coming through for the hard of hearing. And as Martin said, one of your other examples, DVLA, where there's, again, very, very highly scalable, but we don't reach that threshold. We just make sure that we've got the stretchy band to be able to incorporate that scale.
And you alluded to earlier, Martin, some of these systems are doing things like postcodes and things like that. Historically, capturing postcodes in the voice channel was quite a challenge. I think that's got a lot better recently. One of the areas that still I've noticed a challenge with from the testing I've been doing is things like emails and stuff like that. Like, is there anything, I suppose, off limits for what voice AI can do and transcribe accurately? And when you think about use cases in terms of, like, you know, that contact center automation you were talking about, is there anything that you would say is sort of like off limits, or is it at a place now where actually most things, postcodes, numbers, alphanumeric, you know, email addresses, things like that, are they all, is the accuracy, you know,
there are
good?
Still challenges from a speech engine perspective, and then Content Guru address that with some of the post-processing. So numbers, for example, if you just look at natural grammar, when I speak a number, anything from 1 to 10, generally, if you're reading that, you would spell it as ONE or TWO. But obviously from a speech perspective, if they're doing number tracking, credit card tracking, then you want that numeric output to be a numeric output and not a spoken word. The speech engine doesn't know that at the beginning. The speech engine is hearing something and grammatically it's saying, I know how I need to output this. So with Content Guru's platforms, they can do some post-processing. But we are getting to the stage now where you can start to inform the engine behind the scenes so that we can then output. If it's a number that we know is going to be for a credit card, you just do output digits and things like you say with postcode. So you've got that alphanumeric mix. So at the moment, that's a post-processing that the team do. But from an engine perspective, it's how much more intelligence can we build at the back to effectively work as a brain works. So I know when I say a postcode, my brain knows it's a postcode. How do you then inform the engine that it's a postcode? Yeah,
because it's not strictly speaking a speech recognition problem, that is it. It's more of a context of the conversation problem. So, for example, in the postcode example, once you've got a postcode, in some scenarios you might then need to know what the address is. And if I say my postcode is XYZ and my address is flat 22 to the high street, I might be talking about flat 22 at number 2 on the high street. And it's, you know, the speech recognition system will probably do a pretty good job at that. But it's then what do you do with it? Because I suppose it's the context of the sentence that sort of needs the work. Is that where the post-processing comes in?
Exactly. So it's knowing what the options would be that go with that postcode, and then that this flat 222 could only be this flag 2 at number 22. So then we can move on from there. And actually, that's kind of how a human would do it. We'd probably be looking at the postcode software and seeing what the options are, and then choosing the most likely option, or going back and requesting clarification. But obviously, the less you can do of the latter, the better, because again, that increases the frustration and the customer effort score. And if you're asking people to repeat things all the time, they start to become stilted again, and you're losing that human flow of communication. But yes, our role is really taking the output and contextualizing it for the specific application.
Mm-hmm. You mentioned earlier, I think it might have been the 111 example where, or correct me if I'm wrong, if it was one of the other ones, where you said that during COVID, they experienced a lot more calls. Do you have the bodies to answer these calls? ? So then they looked at starting to implement some degree of automation to serve the customer on the front end so that they didn't have to go and speak to an agent in the end. It seems to me as though that arguably is kind of the objective of many contact centres, is it not? I mean, was it, in COVID, I imagine that we've got to deal with these calls, what we've got to do. Whereas now, is the demand from your clients that they want to automate more calls up front, or agent-facing type of use cases, or where's the general demand?
I mean, I suppose assumption is that they want to have fewer people and cut the cost, etc. But really what most are aiming for is, yes, to have a level of efficiency, but actually to provide the best customer experience. And that actually emerged during the COVID era. Suddenly there was a lot more focus on what's this actually like to use? How easy is it? How quickly can we get this individual to where they need to go? Because that is the differentiator between otherwise ostensibly similar services. Think about insurance. You've got a policy, there's a premium, there's an excess. Apart from whether or not the insurer will pay out if something goes wrong, the rest is just down to the experience. Is this easy to work with? Any problems, or have I got the letter that comes through afterwards is inaccurate and I need to go back to them? So if you are a global insurer, say lots of our customers are, you're looking to differentiate and get that competitive advantage. And that matters more than whether you've got an extra 5 people in your contact center or not. And actually, the big thing that excites people in the customer experience and contact center is the ability to make those people who work there much more efficient and effective. One of the kind of heroes of the current stage of AI, Professor Eric Brynjolfsson, Second Machine Age, MIT, Stanford. If you look at most of his field work, it's actually in contact centers, because that's where you've got data, you've got people gathered together, you've already got optimized processes, so it's ready to apply AI to. And in a world where 1-2% marginal gains have been the target for years, suddenly you've got this professor saying 30 to 35%. And obviously, who doesn't want to be a third more efficient with an already optimized operation? And so what you're getting is people racing to apply these efficiencies. And what we've found is it actually makes the experience of working in these places more enjoyable. So the DVLA is a great example, very busy contact centre. I think it's the 3rd busiest in UK government, 60,000 calls a day. So what's happened in the time we've been there, and the speech part is part of it. We also run the chatbot and all the other parts of the contact environment. But the experience of working there has been transformed. I'm old enough to have watched Yes, Minister and Yes, Prime Minister. Yes, and Bernard Woolley, something's going badly wrong at number 10, and he says they're going to send me to the DVLA in Swansea. It's seen as a sort of
punishment,
the death of your career in the civil service. Now, in independent surveys, it outranks the whole civil service and its directorate, the Department for Transport. At the same time, the UK CSI survey rated it the most improved part of government. So it really is a virtuous circle, nicer to use. We don't have that ridiculous chatbot anymore that couldn't answer questions. Nicer place to work, more efficient and effective. So it really is win-win.
And I think that's the area that there's a lot of focus on it, I suppose, from the contact center side, which is on the agent experience, because you mentioned that the contact center is a place where the processes have kind of been figured out. It's already a finely tuned operation for some contact centers. I don't know if that's all of them. But still, they have challenges with agents because lots of agents are using multiple different systems. They've got to know every business process inside out. They've got kind of like high pressure conversations that they're having. It's not all kind of like easy work. It's like you're dealing with irate customers. It can be quite a difficult challenge. And so the people that you need to be technically pretty good because they need to be able to work various different software systems. They need to be socially, emotionally really good because they need to be able to connect with people. They need to be able to deal with stress and they need to have knowledge of the business. It's quite a difficult role to perform, really. So there's no wonder why there's high turnover and attrition and stuff like that. Is there any kind of like other observations that you have sort of on the agent side in terms of how this technology is being useful?
I think, to your point, it's a very high stressful role, even when you're not dealing with NHS, and we've seen not just in the UK, sort of around the world, where you have these huge contact centres starting up where there's lots of people come in, high turnover, and really very little training for those people. But not training, it's not so much around the technology, it's training about their work-life experience and how do they make sure that those agents don't get burnt out. So what we're seeing with the introduction of the AI taking away some of those mundane tasks, they may only then get to speak to somebody that person may be already irate when they get there, but at least they haven't had to go through 20 questions of that person huffing and humming and giving profanity on the phone before they get there. So I think they're much more skilled now at being able to bring those calls in and understand how to process those very quickly. But it is really important from a health perspective, from a mental health perspective, that those agents don't get burnt out either. If you look at how AI has been changing or how AI has been introduced into a contact centre over the last 18 months, because it's scaling very, very quickly. We've heard lots of negativity about, people shutting down, everyone's going to lose their jobs. That's not really what this is about. It's all about driving efficiency. It's all about giving the caller the best experience and making sure that they get the best outcome, but also looking at the welfare of the agents in those centres as well.
And scale as well. That's a big ambition for many companies, is to grow. And every time you add X customers, you require to recruit Y members of staff. And if it's a difficult role to recruit for, which it is, it's as we've mentioned, it's quite a complex role, then the technology helps you sort of achieve that scale, doesn't it? I don't know if that's what you're observing with some of
it
your
does.
clients.
It's all about managing workload again. So in all surveys of people who work in contact centers, workload is always the number one source of dissatisfaction, and that's the driver of churn. And it costs about $10,000 of direct cost to replace someone who's churned, and you're losing all that organizational knowledge as well. And actually, one of our financial services customers, they did a survey globally as part of a big country, double-figure number of country rollout that we're about to do. And they saw that 13.8 was the average number of information systems that their agents were working with. So a lot of that training, and 3-month training is still typical in contact center, was around, you go to this tab here to go there, that information is there, you have to copy this in here. So all of that has nothing to do with actually serving customers. And when there's a change, you've then got to retrain everyone. And of course, when they churn because of this 13.8 system workload and the extra demand we're dealing with and the extra channels, then you've got to do it all over again. So really, a lot of what the speech enables us to do is by having a second pair of ears, we're able to find the information, put it on the screen in front of a contact center worker, and this is basically what you've got to talk about next. And that's not just random information from the internet. This is from knowledge management sources, but kind of curated into a bite size. At the same time, there's real-time sentiment monitoring going on. So we can see if this is a call that's going well, and there's advice flashes up onto a screen what to do to improve it. And everyone wants to improve. You work in a contact center presumably because you want to help people. And so you also want some level of autonomy and mastery, Daniel Pink drive, etc. So if you're able to fix your own performance, while you're still talking to someone, isn't that a lot better than the manager coming down like a ton of bricks at the end of the month when you have a review and this bad call is trotted out? So it gives people a chance to fix things in real time. So across the board, there are just massive improvements to the agent experience. And even before the call is delivered, what has been captured up front, that can be compressed down and then passed through. So you've got the context. Maybe we've sent them a form to fill in on their mobile. We've captured their name, address, date of birth, perhaps. That's delivered with the call while they're waiting in the queue. So you can get straight into the meat of it. Humans are great at the empathy, the decision-making. Machines are great at the collation of information, looking things up. So it's really a marrying of what both are good at to give you this sort of superhuman agent experience that also doesn't require as much training, which, again, if you're the employer, maybe a 1 month training course instead of 3 months. If you do have churn, which incidentally you'll have less of because of the workload being reduced, at least it's going to be less expensive to train those people up again.
That's a good point. Talking about scale, another element of scale for many businesses is that they run geographically in multiple locations. You think of, big telcos and insurance companies, it's like all over the world, which means they've got people speaking multiple different languages. Even locally, let's say in the UK, I don't know the exact numbers, but there's a good percentage of the population that would be speaking English as a second language and speak another language as their primary language. And so can you share a little bit about kind of like how good is voice AI today when it comes to multilingual understanding?
Yeah, it's a really good question. We build our language models. So we build what we call single multilingual language models. And by that, what I mean is when you build, let's say, Arabic, for example, you don't just build it for one region. You build it so that it incorporates the dialects and the regional languages. Our English language model is built with lots of context of people speaking English, but it may not be their own natural language. And so you get all over the world a lot of code switching, and particularly in this country, when you say look at the different language capabilities or the different nationalities we have in this region, and that is a big problem on for the NHS as well. So people calling in, it's that they'll be having a conversation, but they'll interject with their own words. So naturally, when we build out a language model, we bring in lots of context. So again, looking at this natural language processing. So we don't just scrape context of somebody that's speaking English with very good diction. It's real world conversations that we're bringing in that obviously have been published that we can bring into our engine. And so naturally, when the engine gets built, it's being built just like a human brain can hear and understand other words. That's how the engines are being built. So in our English language model, you will often find that if somebody interjects with French, it will recognize it. If it interjects with Spanish, it will recognize it. But what we're doing is we're also building out unique code switching language models. And so the engine then doesn't have to determine what language is being spoken. So from a scale perspective and streaming perspective, it's not taking up much more capacity from that perspective, but it means that we are distinctly building out different language models. So currently we've got English Spanish. We've had English Spanish for quite a while actually, but doing projects in other regions. So in Southeast Asia, so we've built out an English Mandarin model, English Malay, English Tamil, but that means now that from a build perspective, not to give away our secret sauce, we're really looking at, do we get to an omni-language pack where it doesn't matter what language or what words are being output in whichever language, the engine will be able to understand that and transcribe it in the correct way.
Interesting. And is your goal there then to accurately transcribe the target language or to translate into another language, for example?
It depends on the use case. So from a contact center perspective, then you want to be able to take that, interpret that language, so effectively the translation piece. So if I'm ringing up and I've got a health issue and I'm ringing 111, then obviously if I'm speaking in a different language or interjecting in a different language, that's not going to help the agent on the end unless we take that through one of the small language models or large language models. So it doesn't matter what I speak, the chatbot or the agent is hearing it in English. And then taking that stage further, when we talk at the text-to-speech piece, the response is coming back in English, but the person on the end of the phone, whatever language they're speaking, is hearing it in their own language model. So from NHS use cases, for example, you'll get lots of callers calling in a foreign language. And so from our perspective, building out that scale and being able to understand those languages, in some cases it is translating it, in other cases it's interpreting it. So it's a slightly different slant on what that language model means.
So essentially what that means is that you've got the ability to both scale in terms of being used locally in different geographies, but then also taking multiple languages centralized into one language. So for example, if I'm an English speaking contact center, but I have customers calling that speak Arabic or Spanish or whatever, it's all translated into English. Is that, have you got any examples of customers that are using that type of capability?
We're actually piloting that in NHS at the moment, actually, for urgent and emergency care. Right. So typically there, what happens is if you don't speak English or can't speak English, then a translator is sought, and a number of translation services. They're quite expensive. The translator isn't some medical specialist either. It's the same translator that will do the council or the police. So you've got to find a translator in the right language, get them on, with then some back and forth while the translator chats with the caller, and the call handlers all the while effectively man-marked, just sitting there, either waiting for the translator to be found or while they talk to one another. They don't know exactly what is being said either, so sometimes there's some interpretation going on, so perhaps the script isn't being rigorously followed. So there are a number of weaknesses apart from cost. So obviously the goal is that you can translate from any language back into English, and then, and in demo form, it works really well. So, je peux dire quelque chose en français. I can say something in French. And then, so you've got that speech to text, the translation, the text to speech. The difficulties occur once you move out of Europe. So European languages, good. Arabic with its many dialects, hard. Indian subcontinent languages, again, take Bengali. There are multiple dialects, whether you come from Bangladesh or Bengali Indians. And so actually it's those latter ones where there's a lot of the actual demand, particularly in public services. However, it's good enough in European languages. Those are safe to deploy. So it's agreed those can be put out into the world. And then as the other languages are kind of declared safe and ready to go, and they've been through this rigorous test actor, pre-alpha, alpha, beta methodology, then those can be deployed as well. But frankly, even if you're saving 20-25% of a translation because you're able to do maybe Spanish and a couple of other languages, Polish, Romanian, that's a good start. It's enough to be useful. And I think that's a great thing with AI technologies. They're iteratively improving. So the fact that, Yemeni Arabic isn't the best yet, eventually there will be a good Yemeni Arabic engine that will be able to be plugged in. And in America, Spanish is obviously the big one. That's why Spanish works really well. Portuguese works well for the Brazilian population, etc. But here in the UK, if you look at the pie chart, it's a very finely sliced and evenly sliced pie between a lot of languages. So we do have a more challenging environment in this market here.
It's good to know that it's at a place where it's at least production ready for some languages. I remember a long time ago, probably about 4 years ago, perhaps 5, I saw a demo from Bosch, and they were presenting at an event I was at, and they showed this translation thing that they'd built themselves, essentially using a bunch of technologies. And it was a good demo, but it was kind of impractical because the latency was so long that on a voice call, it wouldn't be usable, So it's good to see that it's like, the technology from then has improved so much. If it's now really just a case of language coverage, but the fundamental technology is good enough, accurate enough, fast enough, then that's a huge step for a relatively short period of time.
And what we're seeing with the translation piece is that that's much better now being performed through large language models rather than taking the speech to text and then the text to text to do that translation. Because again, the large language models have got that much more context now and that real world scenarios and information. So the speed of the output of the text is really important, and then getting that conversation back. And as Martin was saying, there is a very slight differential between what is a translation and what's an interpretation. You take, for example, say some of the medical calls that might come through. Just the context of understanding whether it's hypertension or hypotension will have an effect on the type of response that they get. Some drug names are very similar, and so you can't really translate drug names. You need to make sure that the interpretation that's coming across is correct. Border control, it's really important when you get somebody that comes into a country that simply can't speak that language. Getting an interpreter, a human interpreter in, sometimes is exactly that. And so you can't take away bias from those interpreters. A machine doesn't lie. So when the machine's doing the translation through the large language model, hallucinations aside, it's literally saying what that person's saying rather than interpret it. And so you're removing that bias as well from those conversations and making it a much more and fairer experience for that.
Absolutely. Well, thank you both so much. That's been an absolutely amazing conversation, Paulina and Martin. That's been absolutely brilliant. Really, really appreciate it. And thank you all for joining us. Hopefully you learned just as much as I did. That was absolutely fantastic. We've covered a lot of ground there, a lot of tremendous use cases, a lot of great examples of the value that can be seen from applying voice AI in the contact center, lots of intricacies and some pretty deep insights as well, which we got into there, which is fantastic. So thank you both for joining me, and thank you all for joining me wherever you are, and we'll see you again on the next one. Thanks now.